We thought we knew the story of our universe. You know the one. It started with a Big Bang 13.8 billion years ago, followed by a slow, orderly process where gravity patiently pulled everything together. It was a good story. It was a neat story. But what if the story is wrong? The James Webb Space Telescope, humanity's incredible golden eye in the dark, is sending back postcards from the dawn of time. And they show things that, according to our rule book, just shouldn't exist. Things that are tearing up our neat and tidy models of the cosmos. From galaxies that got way too big, way too fast, to hidden chemical factories pumping out the building blocks of life in the most violent places imaginable, the rules are being rewritten in real time. These aren't just tiny little corrections. They are deep, fundamental challenges to our whole understanding of how we got here. Today, we're looking at 4 discoveries from Webb so strange, they don't just bend our theories of astrophysics, they might just break them. So if the idea that the universe can still shock us gets you excited, stick around, because we are heading straight to the edge of what's known. First up, we're traveling back to a time when the universe was just a toddler, only about 1 billion years old. According to our best models, this was the universe's slow construction phase. The rule was simple: gravity takes its time. Little baby galaxies were supposed to drift together over billions of years, like tiny streams gradually merging into a mighty river, to eventually form the huge galaxy clusters we see today. It was a process that demanded patience. But Webb, working with the Chandra X-ray Observatory, found something that throws that entire timeline into chaos. It's called JD's ID1, and it's a monster. This isn't just one galaxy. It's a protocluster, a swarm of at least 66 galaxies, all being pulled together by gravity. Its total mass is a mind-boggling 20 trillion times that of our Sun. To put that into perspective, finding this is like discovering a fully grown blue whale in a petri dish. The real smoking gun was the detection of a massive cloud of superheated gas weaving through the galaxies, a cloud so hot it could only be seen with Chandra's X-ray vision. That hot gas is the gravitational glue proving this isn't just a chance encounter. It's a cosmic metropolis under construction. And here's the break. Here's the part that has astronomers completely floored. A structure this massive and this mature simply should not have existed so early. According to the models, the universe wasn't old enough. The patient work of gravity should have just been getting started. Jade's ID1 showed up to the party about 1 or 2 billion years ahead of schedule. This discovery forces us to ask some huge questions. Is our understanding of gravity on cosmic scales wrong? Or did the invisible scaffolding of dark matter, which galaxies build upon, have some wild properties we never even considered? JD's ID1 doesn't just mess with the timeline. It suggests the physics that builds the universe might be far more dramatic and rapid than we ever dreamed. Our second discovery shrinks from the impossibly large to the impossibly complex. For decades, the rule was clear. The chaotic, violent centers of active galaxies were no place for delicate chemistry. Take a galaxy like IRAS 072510248. It's an ultraluminous infrared galaxy, which is a fancy way of saying it's shrouded in dust so thick it's basically opaque. At its heart, a supermassive black hole is throwing a tantrum. The assumption was that any complex organic molecules, the stuff of life, would be either frozen solid in dust grains or just vaporized by the intense radiation. But Webb's infrared eyes can pierce right through that dusty veil. And what it found inside has completely flipped the script on cosmic chemistry. Using its supersensitive spectrometers, Webb stared into the galaxy's hidden core and read the chemical fingerprints in the gas. It didn't just find a few simple molecules, it found a buzzing, complex chemical factory. The data revealed a treasure trove of small organic molecules like benzene and methane. But the real shocker was the clear signal of the methyl radical, or CH3. This was the very first time this highly reactive molecule had ever been spotted outside our own Milky Way galaxy. Its presence is the break. The methyl radical is famous for being short-lived. It doesn't hang around. Finding it means there's an active, ongoing process constantly churning it out. The carbon in this galaxy's core isn't just locked away. It's being smashed apart and reassembled into new, more interesting things. What truly stunned scientists was just how much of it there was. The amount of these organic molecules was way higher than any theory had ever predicted. The leading idea is that cosmic rays, which are everywhere in these chaotic galactic cores, are slamming into larger carbon particles, shattering them and unleashing a constant stream of organic building blocks into the surrounding gas. The implications here are staggering. These violent, dusty galactic centers, once dismissed as chemical deserts, might actually be the primary factories for the raw materials of life, churning them out and spreading them across the cosmos. Our third stop is a story of beautiful violence and unexpected creation. Say hello to ESO 1370L1, a stunning structure nicknamed the Jellyfish Galaxy. It's a spiral galaxy, a bit like our own, but it's hurtling through a distant galaxy cluster at nearly 2,000 kilometers per second. Now, the established rule for a galaxy in this situation is pretty grim. The space inside a galaxy cluster isn't empty. It's filled with a thin, scorching hot gas. As a galaxy plows through this gas, a process called ram pressure stripping acts like a cosmic hurricane, violently tearing away the galaxy's own cool gas, the very fuel it needs to make new stars. The result should be a slow, quiet death as the galaxy gets bled dry and stops forming stars. It was also thought this process wouldn't be very effective in the younger universe, where this intergalactic pressure wasn't believed to be as strong. But Webb's look at ESO 137L1, seen as it was 8.5 billion years ago, tells a much weirder story. It saw the ram pressure stripping happening in spectacular fashion, with magnificent tentacles of gas being ripped from the galaxy and stretching for thousands of light years. This alone was a surprise, happening so intensely so early in the universe's history. But here's the real mind-bender. Deep inside those tendrils of stolen gas, the very material that was supposed to be the sign of its death, Webb saw the unmistakable glow of newborn stars. The gas being violently ripped away is, itself, becoming a stellar nursery. The destructive force is simultaneously triggering creation in its wake. It's a cosmic paradox where death and birth are happening in the same breath. ESO 137001 challenges the simple idea that this process is just an ending. Instead, it's a force that is both a thief and a creator, scattering the seeds of new stars and maybe new worlds across the vast emptiness of intergalactic space. For our final discovery, we go all the way back to the brink of creation itself, just a few 100 million years after the Big Bang. The standard cosmological rulebook is very clear on this point. Everything starts small. The first galaxies were small, and the first black holes were small, probably seeded by the collapse of a single massive star. Growing into the supermassive monsters we see at the center of galaxies today should have taken billions of years of steady eating. But Webb is looking at this cosmic nursery and finding giants. While the race to find the single most distant galaxy is always changing, the pattern Webb is revealing is undeniable. Webb has found definitive proof of actively growing supermassive black holes in galaxies that existed as early as 400 to 570 million years after the Big Bang. For example, one black hole discovered in the galaxy GNZ11 already had a mass of over 1 million suns when the universe was an infant, just 400 million years old. These aren't tiny smudges. They are significant, developing galaxies with shockingly large black holes already in place. This is the break. There simply wasn't enough time. According to our models, you can't get a black hole that big, that fast. It's like planting an acorn and finding a 30-year-old oak tree a week later. It shatters the known timeline of growth. These discoveries are forcing a complete rewrite of how the universe's biggest objects got started. We're the first seeds for black holes not from stars at all, but from the direct collapse of unimaginably vast clouds of gas, creating monsters from day one? Or did black holes have some secret, ultra-efficient way of growing that we haven't even thought of? These impossible early giants aren't just fun facts. They are direct, smoking gun evidence that our story of the cosmos is missing a critical first chapter, connecting the earliest moments of the universe to the titans that would come later on, a timeline our physics just can't explain. So, what have we learned? A protocluster that showed up billions of years too early. A hidden factory for life's ingredients in the last place you'd look. A dying galaxy giving birth in its own funeral shroud. And cosmic giants that grew to impossible sizes in the blink of a cosmic eye. Every one of these discoveries from the James Webb Space Telescope tells us that the universe is more chaotic, more creative, and frankly, a lot weirder than our models ever gave it credit for. These aren't errors in the data. They are puzzle pieces from a box we didn't even know existed, hinting at new physics just waiting to be found. The story of our universe isn't finished. It turns out we're just getting to the good part. Webb has shown us our rulebook is missing a few pages, and the biggest secrets of the cosmos are still out there, waiting in the silent, star-filled dark.